Data structures are the backbone of efficient algorithms and play a crucial role in solving complex problems. Today in this video, we'll break down the essential concepts of data structures in the simplest technical terms and will provide relatable everyday examples to help you grasp the fundamentals. So let's get started. A stands for array, which is a collection of elements arranged in a contiguous block of memory. For example, a grocery list where each item represents an element in the array. Now B stands for binary search tree, which is a tree-based data structure where each node's left subtree contains only the nodes with values less than node, and the right subtree contains only the nodes with values greater than the node. For example, a phone book organized by the last name. Then circular linked list, which is a linked list where the last node's next pointer points to the first node, creating a circular structure. For example, a circular queue implemented using a linked list. D stands for Dijikstra's algorithm. Now, Dijikstra's algorithm is a shortest path algorithm for a weighted graph that starts at a source node and computes the shortest path to all nodes in the graph. For example, finding the shortest path between two cities on a map with distances between the cities indicated. E stands for Eulerian path, which is a path in a directed graph that visits every edge exactly once. For example, a route on a map that visits every street in a town exactly once. F stands for forward chaining, which is a reasoning based method in artificial intelligence that starts with a given information and applies rules to drive new conclusions. For example, a chatbot that answers questions by following a determined set of rules. Then G is a graph, which is a collection of vertices or the nodes and edges or links that connect the vertices. For example, a social network where vertices represents people and edges represents friendship. H stands for hash table, which is a data structure that has map keys to values using hashing to find the location of the values in the table. For example, a password protected website where a hash table is used to store and compare the passwords. Then I is the insertion sort. Now insertion sort is a sorting algorithm that repeatedly inserts a new element in the sorted subarray of an element. For example, sorting a list of unsorted numbers by inserting each number into its corrected position in the sorted subarray. Then Josephus problem. It is a combinatorial problem where the group of people stands in a circle and are eliminated at a specific intervals. Here the problem asks for the position of last survivor, and this problem can be solved using a circularly doubly linked list data structure. Then k-ary tree. Now a tree data structure where each node can have up to k children. Now this k-ary trees are generalizations of binary trees and are used in various applications such as data compression and multidimensional indexing. L stands for linked list, and a data structure consists of a sequence of nodes, each containing an element and a reference or link to the next node in the sequence. So this linked list are the dynamic data structure that can be easily traversed, inserted or deleted. M stands for merge sort. Now we know a divide and conquer sorting algorithm that merges subarrays to form a single sorted array. For example, sorting a list of unsorted numbers by dividing the list into two halves, sorting each half and merging the sorted halves. Then N stands for node. We know the vertex in a graph or a tree. For example, node can be a city in a map represented as a node in a graph. Then O stands for order of an algorithm, that is big O notation. A notation used to describe the upper bound of growth rate of the resources an algorithm consumes. For example, time or memory relative to the size of input. Example, ON square for the sorting algorithm that has the time complexity that increases quadratically with the input size. Then polynomial time algorithm. This is an algorithm that solves a problem in a time, that is polynomial function of the problem's input size. For example, sorting an array of integers using merge sort. Then Q is a linear data structure in which elements are inserted at one end or the back and removed from the other end, say at the front. For example, a line of people waiting to buy tickets. Then R is the radix sort, which is a sorting algorithm that sorts any elements by individual digits starting from the least significant digit. For example, sorting a list of numbers with up to 3 digits by first sorting the ones digit, then the tens digit, and then the hundreds digit. Then comes shortest path problem. This is the problem of finding the path with minimal total weights or length between the two vertices in a weighted graph. For example, finding the shortest route between two cities on a map with distances between the cities as the weights. Then tree traversal, a systematic way of visiting all vertices in a tree. For example, breadth first traversal that visits vertices level by level. Then depth first traversal which visits vertices as deep as possible before backtracking. Then depth first iterative deepening, which is a variant of depth first traversal that limits the depth of the search to prevent infinite loop. Then undirected graph. Now undirected graph is a graph in which edges do not have a direction. For example, a social network where edges represents friendship between the people. V is a vertex, which is a node in a graph. For example, a city in a map represented as a vertex in a graph. Then weighted graph, which is a graph where each edge has a numerical weight or cost. For example, a map with distances between the cities as weights. Then X stands for XML or the extensible markup language, which is a markup language that defines a set of rules for encoding documents in a way that is both human readable and machine readable. Basically, this XML is widely used to store and transfer data, particularly on the web. For example, an RSS feed, an atom feed, or an XML file describing a web page structure and content. Y stands for yield. In programming, this yield keyword in some programming languages, say Python, allows a generator function to temporarily pause its execution, return a value, and later be resumed from the point of pause. And the generators are useful for creating infinite sequences or lazy evaluation. Z stands for zero knowledge proof. In cryptography, a zero knowledge proof is a method of proving the validity of a statement without revealing any information beyond the validity itself. And this zero knowledge proofs are used in applications such as anonymous credentials and privacy preserving protocols. Thank you.